So, energy audit, just to let you know what we do with the energy audit on the irrigation. You have to get all the farm and farmer information, which is really a struggle. I did a farm energy audit and last year, and I got everything all together. This farm had three different electric service providers. Okay, that's an important part of every seminar. Let's see. Oh, this is the story. See, I went out there, did the farm energy audit, got all the, everything. Got consumption history from these three different electric supply companies, everything. So then I was writing up the report. And every report that I write up, I like to put I scrape off the picture of Google Earth, of the farm, okay, and put it right there on the front page. And so I was, cranking out this report. I kept looking at this picture and I said, boy, it just doesn't look like the right place, okay? And I was trying to remember, because when you're in the farm, it always, it's hard to relate to something from the satellite view. I said, boy, it just seemed, these silos were a different arrangement and stuff. It turned out that the guy had given me account numbers for his dad's farm. So it wasn't even the same location. Okay, so you gotta be careful, make sure that you got the right place, okay? So draw the system, sketch it out. This is very simple, but, and you have to be more detailed than this, okay? You have to say this is a 8-inch, you have to estimate the wall thickness. See, we don't know the wall thickness for sure of the pipes, and that makes a big difference in the flow meter reading. So if the guy knows the pipe, or if he has records, then you can go by that. A lot of times the effective inside diameter is less than new pipe, okay, because pipe gets smaller over time. Okay, all the pipe sizes, all the fittings, all the elevation changes, do all those calculations that by now you're saying, I will never do those calculations. Okay. So I got farm and farmer and contact information on there twice, maybe. Motor, pump, nameplate, data, pump, type, power meter. Okay, this is, and I didn't talk about the power meters yet. That comes up, that's right. Power meter types and constants. Okay, KW and KWH readings, and the water source. Discharge pipe thickness, outside diameter material. I'm reading this slide again. Stop me. All those pressures, okay? Okay, you write all this stuff down. It's a laundry list, huh? Because there's a lot of stuff. Okay, so here's the meters. There's two kinds of meters, okay? One kind is a mechanical meter, and one kind is an electronic meter. Okay, the mechanical meter has a little disc, okay? The disc is rotating in the meter, and you can watch it. So, when this meter is, you're watching this disc rotate, you time how much time it takes for the disc to rotate, okay? There's a number called K sub H, and the K sub H is how many kilowatt hours each disc rotation. So you have your stopwatch, okay, and you let the meter go 10 rotations, and write down how much time it takes, then how many kilowatt hours it used in that period of time. Okay.
You're talking about the one on the right, I assume? Or both of them?
The one on the right is a demand meter. It does have energy, okay, the energy dials here. But this one is actually a demand meter. It's a mechanical demand meter, And I took a picture of it because I thought it was really cool. I had never seen one. I've seen lots and lots of electronic demand meters, but never a mechanical one. So this big dial is demand, and the little ones are energy.
So the one on the left, what exactly are you watching when you're standing there with your stopwatch?
Okay, the one on the left has what's called a caterpillar. Okay, it doesn't have a rotation, but it has what they call a caterpillar.
Okay.
You know, and it's just like, you know, when you download a piece of software on your computer and the little, some people call them thermometers, I think they call them caterpillars. Crawls across the screen and then finally you're done. Okay, so this thing, every rotation, every case of H is one caterpillar. Okay, and they'll switch from kilowatts to kilowatt hours in the same meter. Okay. There's a meter multiplier. One of these little numbers here someplace will have the multiplier. There's a caterpillar, yeah, this one. Then you have your case of H, then you multiply that by the meter constant. I'm sorry, multiplier, to get the total number of kilowatt hours that went through that amount of time. See, that's how much energy is going in. So then you know how much energy is going in. You go through all the efficiencies of the losses, the pump, the motor efficiency, and if it's different than the stuff that's coming in from the utility, you know that something is not working the way it should be.
And often, almost always that's higher than what's coming in. What's going out would be higher.
No, the energy going in is bigger than what you've calculated. Then you've got problems.
Seems backwards.
Well, let me think about that a second. The utility says you've used 100 kilowatt hours and you have calculated, you've calculated 90. It should only use 90, but the utilities moved 100.
So you're calculating what it should use, not what it did use.
Yeah, you calculated what it should use because you've done all those losses and stuff.
Okay.
So, and then, you know, realistically, I mean, how far off are you going to be before you start, you know, really telling the guy to spend, you know, a couple $1,000 on changing a pump or something, you know? It's going to have to be pretty far. But that's how you relate the energy in the meter reading to what you're estimating the system's going to use. This is, I can't remember the first thing I said that was really important. If you take one thing away, it's this. I can't remember what that is. But this is another really important one to take away, and that is, you know, always call the utility to verify those because they are wrong as many times as they're right. Okay, so the thing is the utility multiplier. If the utility says the multiplier is 20, and the thing says the multiplier is 10, then the guy is getting billed half as much money as he should. Okay, then you sit here going, okay, well, how bad do I want to tell the utility that this guy is, you know, getting a deal? Okay. So then what you do is you wait until you really want something from the utility, and then you call and say, hey, I have something for you if you have something for me. No, it really doesn't. Unethical.
Effective though.
Okay, so here's calculations, the flow meter, and this flow meter does this calculation for you. But the flow meter, I thought, read in feet per second. And I think you can probably tell it to give me the reading in feet per second, but you put the pipe size into this flow meter, and then it calculates the flow rate. So you don't have to do this step, but you can calculate the flow rate from that. Here's an example. My 6-inch pipe, 5 feet per second, 455 gallons per minute, 2 acre-feet per day, and 1/10 of an inch for my pivot. Did I send that calculation twice?
Mhm.
Yeah.
God, it was really important. Okay, here's total dynamic head. That's the pressure, the pressure that your pump is seeing, okay? It's got to serve this total dynamic head. It's all the losses. Yeah, okay. I actually put, back in the old days, we used to look up these pressure drops in tables. But now we have these online calculators that are really handy. And they're really much easier to use than the tables, and you have less error. So I would say don't use the table. If you want to use the tables, there's a table here. It comes in handy every now and then when you're just talking to somebody on the phone and they're saying, how big a pipe do I need? You can look up, just this,
What number slide is this? I get that call all the time, and I'm like,
well, what size of pipe do I need?
yeah.
Oh, yeah. Well, yeah, so then you say, well, how much water do you need? And how much pressure do you need to run your whatever it is?
Right.
Okay? And then you say, how long is the pipeline? Okay, so you have to add that friction loss in. Yeah, it's the same method. Oh, I'm glad I've been so useful. You are gonna, you're gonna go back to Katie and say, that guy rocks.
Yes.
Okay, effective fittings, again, pressure regulators on the pivots. Flat pivot, maybe you don't need them. Difference elevation, probably do. Okay, audit recommendations, and one of the slides in a presentation I looked at online had this exact valve, and it had just like water shooting out of it, and it's like, oh, I wish I could use that. But I took this one. It's just water leaking out of the top of the valve. Minimize run.
That would be mine.
What's that?
That's how mine operates.
Extra
Water leaking
sprinkler
out
head,
the
isn't
top. Yeah.
It's
You get extra water that way.
Yeah. Well, the best watered location is right around the valve.
That's right.
Yeah.
It's
Well,
under the haystack.
yeah. So you look for runoff. That one slide I had, and it was a little hard to see because I made the picture so you could see the letters a little more. Boy, you really see where this, was running off and carrying silt with it. So you just look for the things like that. Monitor soil moisture and use the data to shut your pivot off. Turn the system off. If it's rained for a week, shut the pivot off, for God's sakes. Convert to gravity feed. Yeah, that's a good one. If you can somehow do that. That is capital intensive. Pipe is expensive. The fittings are expensive. So it's a tough one. I've been working on this one, and the guy keeps calling me up. I got a new source for the pipe. It's $85,000 now instead of $110,000. So then I have to go through all these calculations again, see if it's cost effective. And it's tough. Install the correct pump. A lot of times people put pipe in that's too small because small pipe is cheaper. Okay, but if it's going to be cost effective to put in a bigger pipe. And so if those pressure drops up that pipe are too high, you might have to tell the person to bite the bullet and put in a bigger pipe. Okay, here's my cool thing, and it's really neat because we have some in this building, so I can show them to you. variable frequency drives. Now what these do is, in the old days, when we wanted to control the volume output of a pump, we would put a valve on the output of the pump, and if we needed less flow, we'd shut the valve, okay? The pump bypasses internally, okay? And as long as we don't shut it completely off, it won't explode, but it's less efficient, okay? I lied about that. It's actually more efficient through part of the pump curve, but when it gets really small, it's much less efficient. Okay, well, variable frequency drive makes it way more efficient. The power requirement of the pump goes down as a cube of the speed. So even if you can drop the speed 10%, the energy cost goes way down, okay? So when this comes into play is when you have a difference in elevation in the pivot, okay? So sometimes the pivot is down here, you want 40 PSI at the end, you can turn the pump down and you just have a pressure sensor on the end of the pivot saying 40 PSI, the variable speed drive will automatically slow down so that last sprinkler gets its 40 PSI. Now when the pivot is uphill, the variable speed drive kicks up and runs the pump faster. And the kind of cool thing about it is you can run the pump faster than 60 cycles or faster than 1800 RPM. So you've got more flexibility in this pump. So,
Don't they have a lot of domestic wells on the variable pump?
Okay, when you say well, that makes me think probably not, because
I've got a variable speed pump on my well
on your well.
for my house.
Okay, so how?
As well as my gravity feed system. I'm all about
Man, you're
being efficient
awesome.
and energy.
Okay, well, here's the thing.
She
Here's
comes you
the
over
thing.
and cheer you.
I'm all about being cheap, man.
Well, and it depends on the well depth. Okay.
Right.
So, if
Don't know about people that
if this is really deep, say this is,
You can hear it. You can hear it gear down. Like if you turn on something, and then if you turn on a couple of other faucets, you'll hear it power up.
Okay.
But then if you shut all those down and you just have like a trickle of water, you'll hear it. The low, like it goes down to a low hum, and you can hear it. And then
So it must not be a very deep well.
It's 100 feet.
Okay, that's not, I wouldn't say that's very deep.
Not compared to my 300 liter.
Well, yeah, and I mean, we get wells of 600 feet,
Right. Well,
Okay.
I would have sold the property if I had to go that deep. So that was my.
Okay, but that's 100 divided by 2.3 PSI. And so it's
Almost 40.
40 something. Okay, so let's say this is 40 PSI, and then, and that's always there. Okay, that's static. Okay, so,
Yep, and that's exactly what the stack is, 40.
well,
Static.
then you want 40 PSI at your faucet, right? So your pump is down here, this is where the pump is, and it's running at 80. Okay, when everything, and it wants 80. But as long as this is 80, okay, so basically you've got a pump curve or a system curve. Here's 80, here's 40. The pump curve goes like, or the system curve goes like that. So you can only vary this top half. So it's probably okay. That's not a very deep well. But if the well is, if you want 40.
Oh, I did an eraser.
Here.
If you had a 600-foot well,
Right.
and you just need 40 psi, 600 feet is, let's just call it 2, but say 300 PSI. So here's 300 and here's 340. Okay, PSI. You see the system trend is there. You can only vary the speed that much. And so in that case, the cost of the variable speed drive, this is about 10% of the total range of the pump.
Okay.
So yes, this is not going to be as cost effective as yours, where you're at 50%. You can vary at 50%. Because you've got to get here. You've got zero flow. Remember, here's flow here. 0. So you got 0 flow there. You have to have more than that. So the pump has to work that much just to get it to 0 flow. But those are very cost effective. And we got a couple of them in here, and one of them was working. And when we've got this flow meter set up, and we can control this variable speed drive and set it down and up to show you that it actually does change the flow in this pipe.
And that you got your money's worth.
The flow meter does work.
It appears to work.
As long as it's precisely 0.1 inches apart from the other.
Calibrated. You guys know about these NRCS programs, right? Equip and CSP. I've done energy audits. I've done energy audits with CSP. I haven't ever done an energy audit with Equip, but I can do them. So yeah, if you run into somebody that's dying to have an energy audit, the Equip pays a big chunk of the cost of the audit. And I don't have the numbers with me, but it's a substantial part of the cost of the audit, the NRCS.
Not more than 50.
Okay.
So this fall, watch for some stuff.
It's really good, and where it might, I think it could pay more than 50%.
Yeah.
Because it's a fixed amount. And in Montana, the thing that kills you on these energy audits is drive time. Oh, you gotta drive to Haber, for God's sake.
Beautiful
Kills
out
you.
here, what
And they don't even have a pivot, it's all dry land.
Yeah, what's up with that? I mean, that's something we can put the flow meter on there that had a ground source heat. Ugh. Okay, so there are utility programs, Black Hills Power. Anybody in that territory? No. They just have a rebate for VFDs, variable frequency drives, that's VFDs. Montana Dakota Utilities, energy efficient motors and VFDs. They're just rebates, okay? Northwestern Energy has custom incentives for irrigation efficiency, and it's a cost share for efficiency improvements, can be system design, just about anything. But the kicker is it has to be cost effective from the utility's point of view. In other words, it's got to save enough energy to pay for the capital improvements from the utility perspective, okay? And that is tough. But this is something we're putting a pivot in, converting from wheel line to a pivot. They might, kick into that. And if it is cost effective from the utility standpoint, they'll pay 50% of the project cost. So that's really significant. Like this gravity feed system, if I can,
Irrigation reservoir.
the energy value is about $75,000. So I keep telling the guy, I said, get the project cost down less than $75,000. The utility will pay half of it. But it's a go, no go test. If it doesn't meet that cost effectiveness, they won't pay anything. So it's not like a graduated scale or anything. It's crazy. Okay, and I meant to put more on this for best references, but I'll tell you, through all this stuff, the best reference for sure that I have found was this NRCS irrigation toolbox. There's probably 12 PowerPoint presentations that like are way, way better than this one. I mean, I know it's hard to believe, but way
It doesn't
better.
have wavy grass.
What's that?
It doesn't have
It
wavy
doesn't have
grass.
wavy grass.
No, that's
Yeah, what are the
right. How about
backgrounds
that? See them? But and all of these, all the technical stuff for system design and how to pick the sprinklers and all that stuff is on that irrigation toolbox. Excellent, excellent resource. So I think that's it.
Yeah, let's go look at the pump. That'll do the
Yeah, now we look at the pump. And so we're gonna, or the flow meter.
flow meter.
And we get to turn the thing up and down, and it's just like a circus.
And you don't have to film in there. You don't have to film in there on that piece.
Okay. I can if you.
No, that's all right. We'll get an opportunity.
Okay.
If they didn't come, they don't get to see it.
Yeah, they're not gonna get to use that thing anyway.